Okay, important bit of terminology here. A zero of a function is a number that when you plug it into that function, what you get out is 0. That is, it's a solution to the equation where you set that function equal to 0. For example, if our function is f of x equals x squared minus 3x minus 10, the number negative 2 is a zero of that function because f of negative 2, if you evaluate negative 2 squared minus 3 times negative 2 minus 10, that equals 0. And then the number 5 is also a 0 because f of 5 equals 0. May take a little getting used to say things like 5 is a 0. What do you mean 5 is a 0? I thought 5 was a 5. Well, the number 5 is a 0 of that particular function. So, like I just said, negative 2 and 5 are zeros of that function. But that function is a polynomial that can be factored into x plus 2 times x minus 5. Notice if you multiply that back out, you get x squared minus 5x plus 2x, so there's your minus 3x, minus 10. So x plus 2 and x minus 5 are the factors of that function. Notice how negative 2 is a 0, and x minus negative 2 is a factor. 5 is a 0, and x minus 5 is a factor. If we took our function and set it equal to 0 and looked at that as an equation to solve, x squared minus 3x minus 10 equals 0, well, one way to solve that equation is by factoring. So we can factor this into x plus 2 times x minus 5, and that's equal to 0 when either x plus 2 equals 0 or x minus 5 equals 0, which means x equals negative 2 or x equals 5. So negative 2 and 5, what we earlier said were the zeros of that function, are solutions to that equation that we have when we set the function equal to 0. And then here we have a graph of that function. This is the graph of the function f of x equals x squared minus 3x minus 10. Notice where the x-intercepts are on the graph. Here at negative 2 and here at 5. That's showing you that when x is negative 2, y, or f of x, is 0. In other words, negative 2 is a 0 of the function. And f of 5 is 0. So 5 is a 0 of that function. So notice the relationship between zeros of a function, like a polynomial, factors of that polynomial function, solutions to the equation you get when you set that function equal to 0, and the x-intercepts of the graph of that function. Those all go together. If you know any one of those, you know all the others. So when f is a polynomial function and a is a real number, all of these are equivalent. X equal to that number being a 0 of the function, x equal to that number being a solution to that polynomial equation where f of x equals 0, x minus that number being a factor of that polynomial, and the point where x is that number and y is 0 being an x-intercept of the graph of that function. Like I said, if you know any one of those, you know all of them. Some examples to look at. For the polynomial function negative 3x squared plus 2x plus 60, it can be factored into negative 3 times x plus 2 times x minus 10. X plus 2 is one of the factors, so negative 2 is one of the zeros. And it's also one of the x-intercepts. X minus 10 is one of the factors, so 10 is one of the zeros. And it's also one of the x-intercepts. For this function, y equals x cubed minus 2x squared minus 11x plus 12, notice where the x-intercepts of the graph are, -3 and 1 and 4. And notice what the factors are, x plus 3 and x minus 1 and x minus 4. One factor for each x-intercept. And what are the zeros of this function? Well, those would be -3 and 1 and 4. We could plug any one of those numbers in for x, and the value of the function would be 0. For example, if I plug in 4, well, let's do it in the factored version. 4 plus 3 is 7, times 4 minus 1 is 3, times 4 minus 4 is 0, and anything times 0 equals 0. How about this one? The function x cubed minus 13x squared plus 51x minus 63 factors into x minus 3 times another x minus 3 times x minus 7. The zeros of this polynomial are 3, which actually counts twice, and 7. And the x-intercepts are at 3 and 7. Suppose we want to find a polynomial function with zeros 9 and -6. So we want to write down a polynomial where if you plug 9 in for x and evaluate, it comes out to equal 0. And if you plug in -6 for x and evaluate, you come up with 0. So for 9 to be a 0, that means x minus 9 has to be a factor. And if -6 is going to be a 0, x minus -6, otherwise known as x plus +6, has to be a factor. So we've got our factors, x minus 9 times x plus 6. If you FOIL that out, x squared plus 6x minus 9x minus 54 is x squared minus 3x minus 54. So there we have it, a polynomial function where 9 and -6 are both zeros of that polynomial. So you can check. If you plug in 9 for x and evaluate, you get 0. And if you plug in -6 and evaluate, you get 0. Let's try this. Find a polynomial function with zeros 1, 4, and 0. Well, x minus 1 has to be a factor, x minus 4 has to be a factor, and x minus 0 has to be a factor. Of course, x minus 0 would just be plain old x. And if we multiply this out, first of all, if you multiply x minus 1 times x minus 4, you get x squared minus 5x plus 4. Then we have to take that and multiply it by x, and we get x cubed minus 5x squared plus 4x. So there we have it. That's a polynomial function with 1, 4, and 0 as zeros of that polynomial. Find a polynomial function of degree 3 with 0, -10. Okay, if we want -10 to be a 0, what has to be a factor? X plus 10. Now, if that's the only factor, then we'd have a degree 1 polynomial. For it to be degree 3, we need to take x plus 10 times something else so that when you multiply it all out, it does involve x to the third power. One possibility would be for the something else's to be 2 more copies of x plus 10. Then -10 would be the only 0. It didn't say that -10 had to be the only 0, but if you want -10 to be the only 0, and you want the degree to be 3, here's how you can do it. Just take x plus 10 times x plus 10 times x plus 10. Because then if you multiply that all out, you get x to the third power plus 30x squared plus 300x plus 1,000. But that is a degree 3 polynomial, and -10 is a 0. It's the only 0. Another possibility would be if we took x plus 10 times x squared. Then if you multiply that out, you get x cubed plus 10x squared. So there's a degree 3 polynomial with negative 10 as a 0. For that one, 0 itself is also a 0. So negative 10 isn't the only 0, but it is a 0. And so those are only some possibilities, but you can take x plus 10 times anything else, as long as you have a couple other factors, then you get a polynomial with degree 3 and 0, negative 10. What if we want a polynomial function of degree 5 with zeros 3, 8, 13, negative 22, and 99? You may leave it in factored form. Good. Well, if 3 is going to be a 0, x minus 3 had better be a factor. The other factors are going to be x minus 8, x minus 13, x minus negative 22, otherwise known as x plus 22, and x minus 99. So here's what that would look like. F of x equals x minus 3 times x minus 8 times x minus 13 times x plus 22 times x minus 99. And it's a good thing it said you may leave it in factored form. Because if I were going to multiply that all out, if I were just doing that by hand, that would take a lot of work. I could start by multiplying x minus 3 times x minus 8, just with the FOIL method, and that would give me x squared minus 11x plus 24. But then I'd have to multiply that by x minus 13, and that would give me x to the third power plus some other stuff. Then I'd have to multiply that by x plus 22, and that gives me something that starts with x to the fourth power and then has a bunch of other terms. And then I'd have to multiply all of that times x minus 99. When I multiply that all out, it would start with x to the fifth power, and then it would have a bunch of terms after that. So it would be a degree 5 polynomial. In fact, here's what it would look like. I didn't do this myself. I put this into, well, Wolfram Alpha is a website you can go to and type in an expression like this one, and it'll do the dirty work for you. So it told me that when you multiply this all out, here's what you get. It is a degree 5 polynomial, and if you wanted to check, you could plug in any one of these 5 numbers in place of x and do the calculations, and it should come out to equal 0. Those are zeros of that polynomial. But I wouldn't expect you to go from here to here. I would expect you to just leave it like this.